Hello, my name is Simon Pongtawongsa. In this video, I am going to demonstrate the experiment 6 characteristics of electrical diode and rectifier diode. So in this experiment consists of 4 parts. Part 1, we're going to study about the characteristic of electrical diode. So in this part, we need to have potentiometer, a DC source, and resistor of 270 ohm and a diode. And here is the circuit that we are going to study. So in the worksheet, we have 5 voltage, and that's why I have here 3 battery. So when it add up, it would have the value of 4.5, so it's close enough to 5 voltage. And we have potentiometer, which is connected to a resistor and a diode. So the resistor and the diode are connected in series, and this has the value of 270 ohms, and this diode is now reverse diode. So we want to measure the voltage across the diode here, and also we want to measure the current across this resistor. So we now gonna start simulation. So here the voltage here is 0, while here the current is 0, while the voltage is 4.5 voltage. So when we train this potentiometer, as we can see that the current is remain constant, but the voltage is changing according to potentiometer. So this is because this diode is reverse. That means it blocks the current to flow in another direction, because the diode works in one direction. It's let the current float in one direction. So if we train this diode to be the opposite, then the current would change. So let's try this. And then we connect this again. Okay, here let's start to simulate. And now we can see that the current in this circuit is also changing when we train the potentiometer. As we can see here, the voltage is changing, and also the current is changing. So this is what we called forward voltage. So the voltage flow in one direction. So that's why when we train the direction of the diode, the current remain constant, which is 0. So that means the current cannot flow to the diode. So the next part 2 of the experiment, I have drawn here already the circuit of this experiment. So basically in this part, we need to have 12 voltage. of the AC source. So here I have two battery, which is 1.5 voltage, and then we add up would give us 3 plus 9 would give us 12 voltage, exactly what we wanted. And this circuit consists of two resistors, and this one has the value of 270 ohm, and this one has the value of 22 kilo ohm. 22 kilo ohm is connected in parallel to the diode, and then they are connected in series to the first resistor, which is this one. So in this experiment, in this part, we want to measure the voltage across this diode, and also the current that across this resistor. So let's start simulation. So here the voltage we can measure is 5.4, and the current through this resistor is 260 microampere. So now when we change the second resistor to be 10 kilo ohms, would give us different value of current and voltage. Let's try. So as we can see here, before when we set this to be 22 kilo ohms, the value of the voltage is the same to 10 kilo ohms, but the current is different. So where we try again with 1 kilo ohm, this is the value in the worksheet. So now we try with 1 kilo ohm, and then we start simulation. So in this part, the voltage across this this diode is remain constant, but the current flowing to this circuit is changing when we change the resistance value here, the resistor value here. So that is for the part 2. This basically just to show the experimental result in voltage and in ampere of the circuit. And in the third part of this experiment, we have a circuit here, which is this one. I have already drawn. So in this circuit, we have a function generator with the control setting 50 Hertz of the frequency, and the amplitude is 14, which is peak-to-peak voltage. And DC offset is 0, and we set this to be the psi function. So we connect this negative panel and positive panel to this breadboard, and in this part we also need a resistor with the value of 1 kilo ohm and a diode. So we want to see the experimental result that will be shown in this oscilloscope. We measure in this resistor, and also we measure the experimental result of the AC supplied here. So let's start simulation. And as we can see here, it's what we call a half-wave rectifier. So this is the function, the graph of the source here, the AC source. We can measure, and it has the result as shown in this oscilloscope. And we also have the half-wave rectifier circuit. This is measured from the resistor, which is start from 0, and then it's increasing to its maximum, and then decreasing to 0, and then increasing again and again, and on like this. So this is what we call the half-wave rectifier circuit. So this is measured from the resistor here. So that is the result of the part 3 of this experiment, half-wave rectifier circuit. And the last part of this experiment is full-wave rectifier. So I have drawn here a circuit of this part, full-wave rectifier circuit. So in this part, we need to have 4 diodes, which are connected in stone bridge, or like bridge form. We also have a resistor that is connected to this bridge. So we have the control setting here, 50 hertz of the frequency and the amplitude of 10, and offset is 0, and this one is psi. So this now circuit, we can analyze that. These I will name it as diode D1, 2, 3, and 4. So the positive channel goes to this 1 and 4, D1 and D4. So it's come here, and then the negative channel come to the end of the connection of D2 and D3, and we have the resistor which is connected to in between D1 and D2. So we connect this resistor to, in between D1 and D2, and then we connect another end to D3 and D4. And we now want to see the result that is going to show us in this oscilloscope. So we measure from this resistor. So let's start the simulation. So yes, this is the result of this full wave rectifier circuit. And if we train this the direction of this one, what would happen? So we train it to be and now start simulation again. So So yes, by the way, this is the result of the experiment of the part 4 of this experiment. This is for part. It is for part number 3. Train this election of the diode, and then it would give us the opposite direction. As we can see before, it's half-wave rectifier, and it is negative half of the result. And if we train this, we would have the positive part. So that's it for the experiment number 6 in Tinkercad. Thank you very much.